Okay, so I think we are ready to start.
Okay.
Vladimir, now you take point.
Yes, thank you. So welcome everybody to the Scientific Computing Infrastructure section. Today we have the second part of our workshop. And in this part we will have 4 talks. And the first talk is by Anna Golovkina, Vladimir Kazinchenko, and Natalia Kulabakhova, Reconstruction and Identification of Dynamical Systems Based on Taylor Maps. Natalia is the presenter. So Natalia, welcome. Please share your screen. Yes, we can see the slides. And the floor is yours.
Thank you. I think everyone can hear me. So, good
Natalia,
morning. Good morning. Yes.
Somehow the sound is not clean. Maybe a bit further from it. Say something.
We will try.
Чуть подальше от этого.
But this is, I can't. Maybe this way. I will try.
Как слишком громко идет, пропадает. So it's a bit too loud.
До этого было нормально?
Ну, сейчас, по-моему, получше немножко.
У меня наушники, поэтому я не знаю. Я попробую, конечно.
Ну, вроде ладно. Okay, let's try like this. So I feel the sound is a little bit unclear, but we can hear you. So
I'm sorry for technical problems. Good morning, everyone. So I'm presenting the work of my team, reconstruction and identification of dynamical systems based on Taylor maps. Dynamical systems reconstruction and identification from time series data is crucial for many applied problems, industries, and experimental research also. This is explained by the necessity to interpret the data to understand the underlying process and predict its behavior in future. Identification and reconstruction belong to the class of inverse problems that are usually ill-posed, meaning that many standard numerical methods cannot achieve high accuracy when solving them. The approach is described in literature dedicated to dynamical system identification, usually keep in line with one of these directions, white box, gray box, and black box models learning. White box models are based on first principles that are often expressed as systems of differential equations containing unknown parameters describe the concrete physical situation. These parameters are usually defined though the optimization of least square error between as the least square error between the measured and the modeled data. However, in many cases, such models are complex and hard to obtain because of the nature of many systems and processes. Another very important approach in dynamical systems identification are gray box models. They use both insights into the system, for example, in the form of conservation laws and black box models to infer hidden parameters. Usually, this group of methods requires both statistical data and numerical solvers to build the model and estimate its parameters. And on the other hand, for those two are applying black box models as machine learning methods. They allow us to avoid numerical solvers complexity and extract the complex behavior of the system on the other way. Though some studies demonstrates the application of neural networks for physical systems learning, the described methods require large volumes of measured or simulated data for neural network training. Otherwise, they are likely to lead to unsatisfactory performance. The idea of these methods is building surrogate models that can replace physical-based ones. Some authors suggest the gray box models incorporating neural networks into the differential equations to approximate unknown terms. Some studies propose dynamical systems learning from partial observations with ordinary differential equations, while others add neural networks to partial differential equations. And backpropagation technique through an ordinary differential equation solver is proposed in some other works, but requires traditional numerical solvers to simulate the dynamics. Our research aims to combine the strengths of the mentioned techniques to build an approach suitable for identification of wide variety of dynamical processes with small training data. And moreover, the recovered model is required to read the dynamics for new beyond the training samples. To solve this problem, we consider a polynomial neural network for special architecture approximating the general solution of a system of ordinary differential equations in the form of Taylor map. This means that the physical description of provided data is preserved, but it becomes possible to use modern methods of training neural networks to adjust the coefficients in accordance with the collected data. A polynomial learning algorithm have three successive steps. The first one is the reconstruction of system of ordinary differential equations with a polynomial right side with only one sample. Then Taylor mapping representation of the general solution, and the third is the initialization of polynomial neural network weights based on general solution representation. The transformation matrices defines the Taylor map in the form that you can see on the slide. The transformation is linear in weights and nonlinear with respect to the x0. In the literature, this transformation can be referred to Taylor maps and models tensor decomposition matrix which transform exponential machines and some others. In fact, this transformation is just a polynomial regression with respect to the components of x that directly defines the polynomial neuron. The general view of such a system you can see on the slide. If the system of ordinary differential equation is known, the weights in the matrix can be calculated directly. Initialized the Taylor map form of orders represents the dynamics of the system without the necessity of using numerical solvers. this property of polynomial neural network based on Taylor map allows us using it as a representation of dynamical system. So, we need Taylor map approach to use the approximate to approximate the general solution of the system that corresponds to the polynomial neural network, initialization of weights and their function based on the measured data. And the following slide contains the description. The following slides contain the description of reconstruction approach of a system for the differential equation from the data and Taylor mapping technique to identify its general solution. So the reconstruction. The main our assumption about the collected time series data describing the multiple parametric dynamical process is that it approximately follows autonomous ODEs system with a polynomial right-hand side. Matrices P are usually unknown, so we should approximately find them from the measurements. The system of equations you can see on the slide is a system of linear algebraic equations that can be written in a matrix form where matrices A, P, and B are of this form. An interactive algorithm for constructing an approximate solution for nonlinear equations is based on the technique introduced in our previous works, and starting from the linear term in the right side of the equation, you can see here. We successively increased the order of polynomials to the required degree of linearity. The next time I show some examples. The first one is that we consider an approximation of particle motion in cylindrical deflector written in the form you can see. We generated training data as a particular solution of the system with the initial condition x0 minus 2 form. And the training set includes 27 points. After the solution was generated, the equation is not used further. Then this generated trajectory is used to reconstruct the system of ordinary differential equations till the third order of nonlinearity according to the algorithm that was described. And then using the approximate system, we find the matrices of weights L11 and L12 for the different values of t according to the algorithm, also according to the algorithm. So this is an example of comparing the numerical solution of equation with the Linguistic method blue line and the solution we obtain for the initial conditions, so our red line. And we also test this our method in the case of beam dynamics, the general solution of the equation of motion in the linear and nonlinear case you can see on the slide, and we calculate matrices of control elements in the symbolic form, so it turns out quickly. And we can prepare these matrices before we exactly calculate, before we make some exact calculations. So they are prepared and just waiting for the work. And it can be used for any dynamic system, not only for accelerator physics, beam dynamics, but it's just an example here. So our work is in progress, and we are planning to use this method in some other cases, more complex, more difficult, and this is our goal for the future. Thank you for your attention. Ready for questions.
Natalia, thank you very much for your talk. Please, anybody has any questions? I have a small question meanwhile. Natalia, so you were talking about some examples like cylindrical deflector and all this accelerator physics as one of the applications. But can you suggest any more generic applications for this approach? What can this be used for, like something else, not only the accelerator physics?
Oh, thank you for your question. We are going to, this next our step is to use it on some, in industry, in car development process on, so it can be used to help the production of cars to check the errors during the work process, the working process of car making and so constructing.
Thank you. More questions, please? So we do not have more questions. Natalia, thank you again.
Thank you.
And we welcome our next speaker. And the next talk is by Stanislav Baczynski and Alexei Stankus. Isolation and comparison of company names in the news text with stickers of companies traded on stock exchanges. Do we have Stanislav here? Yes.
Yeah, I do.
Okay, Stanislav, welcome.
So, 1 minute. Hello, my name is Stanislav, and I will talk about the article Isolation and Comparison of Company Names in the News Text with Stickers of Company Trades on Stock Exchange. News is the change and reflection of some fragment of reality, timely covered in the media, which is of interest and value to a large number of audience. Thousands published daily containing information about everything that happens around us. News analysis is a cornerstone for predicting price changes and volatility in stock trades on stock exchanges. Identifying the company that is being talked about in the news is the first step toward predicting the stock price using the news. There are numbers of work aimed to extract company names from news, but in this article discusses approaches that allow us to select the name of companies from the text of general news, as well as methods we have developed that allow us to compare the resulting name with a possible ticker of a company. During the work on this article, we used news collected from BBC News, Business Wire News, Brainbot News, CNN, the New York Times, Reuters, Washington Post, Trust Notes, and Yahoo News from January 2018 to October 2020. In total, 988,000 texts of various news were collected. 100 news were selected from the general list. 62 unique company names were manually allocated in this news, and 21 unique company names of companies listed on the NASDAQ or NYSE stock exchange were manually assigned the corresponding stock tickers. We also use the list of companies listed on the NASDAQ or NYSE stock exchanges. To match the names of companies mentioned in use text and tickets of this company straight on exchange requires the solution of 3 subtasks. The first one is extraction of company name from use text. The second, optimizing description tickets. And the final one, compare highlighted company names in use text and optimize ticket description. To solve the problem of extracting company names from use text, 2 methods were applied: the method of linguistic analysis and neural networks. Linguistic analysis method is based on sequential iteration over the word or the new text. The main components of the method are shown on the slide. The disadvantage of this approach lies in its essence. The method is heuristic. To effectively identify company names, a large list of trigger words is required, which can be generated by manually marking use text. However, the main disadvantage is that the company name must contain a trigger word in order to be identified. The phrase Amazon Inc., the considered method was successfully defined of the name of the company, but the words Amazon or Amazon.com would be omitted. The method is effective for highlighting company names in the text of financial use, in which fully company names are indicated, containing suffix or other indicators. Another approach to solving the problem of extracting company names from the text is use of neural networks called NER, Name Entity Recognition. Unlike the previous described method, the neural networks identify company regardless of the completeness of their name. However, it gives a high percentage of false positive errors. For example, the words and phrases that appear in company names, like football, Cesar Basanta, USA, African Basketball League, Bluetooth. However, for us, it's more important not to miss the loss of company names in the use that to get unnecessary meaning with that will be discarded in the final step, matching the highlighted prospective company names with stock tickets. So the next stage is optimizing description tickets. The name of company used on the exchanges consists of 4 parts: a distinctive element, a descriptive element, a corporative element, and an additional element. A distinctive element can be a personal name, a place name, or a made-up word. The descriptive element is need to describe the nature of business and allow to distinguish between companies that have the same or similar distinguished elements. The corporate name is a suffix that carries information about the type of company. And the additional element identify as stock, not a company. To correctly match company names from the news text and company names from the stock exchange, the additional element should be removed. The final stage is matching the highlighted company to the tickets. The idea of comparison method for hashed sequences is to find the longest matching subsequence that does not contain unnecessary item. These unnecessary items are in some uninteresting. For example, blank lines or space. The same idea is then applied recursively to the position of sequence to the left and right of the corresponding subsequences. This doesn't not result in minimal edit sequences, but tends to produce match that looks good to human. The algorithm is effective for comparing slightly different word or sequences, but is not suitable for comparing the results of method for undefined potential company with stock tickets. Since the phrase representing a potential company found by the neural networks method often contains words that are not included in the name of company. For example, Morgan Stanley have extracted from news and its corresponding Morgan Stanley tactical value investing, a weak similarity ratio, and the phrase root blocks in has a stronger similarity to company Riot blockchain. The developed algorithm allows us to remove a restriction of the presence of unnecessary word in the studied phrase. On the slide shown a diagram of the algorithm for matching the selected from news words of phrase and the name of company from the stock exchange. The algorithm uses processed company names from the stock exchange, stock tickets, and words and phrase extracted from use, presumably being company names. As a result of the method of successive exclusions, the identified phrase is marked as ambiguously defined or undefined. The resulting value is entered into the database with the tickets of corresponding company. Method for extracting company names were tested on the test database of 100 news. Manually, analysis showed that in these 100 news items, there are references to 62 unique companies. The result of experiment showed that the linguistic method is not suitable for solving the problem of separating the names of company from text of ordinary non-financial news. And the result is less than 13% of the total number of companies mentioned. The method using neural networks shows a significantly better result, 92.5%, but it is worth nothing a very large number of unnecessary phrases that are perceived as a company names and interfere with further processing. The method of comparing companies and stock tickets was tested on data obtained from the following initial processing, checking the observation of the method of sequential eliminated from the Hesteld pattern method on the names of company make manually. Checking the method of successive elimination and Gestalt pattern method on the result of the linguistic method, checking the method of successful elimination and the Hestad pattern method on the result of neural networks algorithm for extracting company names from the news. During manual checking was received 62 unique company names, of which 28 names corresponded to specific tickets. 34 corresponded to an empty ticket. The experimental results are presented on the slide. All percentages are calculated from the correct number of tickets. The Hestad pattern method shows an average result when you manually isolate company names. But when you add random words that fall into phrases, the accuracy of the method drops significantly to 57.1%. With a large amount of garbage data, the method gives a large number of errors. The sequential elimination method shown an excellent result, is 100%, with the good isolation of the company names from the news, and a good result with the presence of unnecessary word or phrase. The experimental result showed that method based on neural networks showed good result in identifying company names, but they carry a large amount of garbage that contaminates the data obtained, which ultimately leads to slight but increase in error in the best of the algorithm for matching the company to the exchange tickets. To improve the result, it is necessary to concentrate of training neural networks for a more correct selection of company names with described in the amount of necessary information. That's all. Thank you for your attention.
Stanislav, thank you for your talk. Please ask questions to the speaker. I have a general question, in fact, somehow similar to the one I asked the previous speaker. So you are trying to find particular tickers in the text, but what do you plan to do with them? So what is the general goal of this work? So what is the application that you try to implement with this method?
This article is the first step to predicting the stock prices using the news. That's all?
Mm-hmm. Yes, but can you add more details? So that's secret.
No, it's not secret. So the idea is a count of frequency of mentioning some company names in use to predict volatility or stock price.
Mm-hmm. So you probably also try to analyze automatically the context of the news. Is it positive or negative and something like that?
Something like that, but it's not about positive or negative. It's about they they have an impact or not. So if the company is mentioned in news few times, but in ordinary time it's not, it's meaning that the stock price will grow or low.
Okay, thank you. I think that's the good answer. Do we have more questions to the speaker?
If we have time, I just want to ask about do test your method with the data that has some outliers, maybe, or some not correct data.
Yeah, a very tested method on a data with a lot of garbage. So the method is worked properly and shown a good result.
Okay, thank you.
Okay, thank you, Stanislav. So we have to move on. And the next talk is by Ruslan Kuchumov and Vladimir Korkhov, an analytical bound for choosing trivial strategies in co-scheduling. So Ruslan, welcome.
Good morning.
Good morning.
1 second.
Let's try to share the screen.
So as I can see, it's working. It's great.
Yeah. Yes.
Oi. So do you see the presentation?
Yes.
Hello?
Yes. So please.
Okay, that's great.
Please.
So I'll start then. The topic of my presentation is an analytical bound for choosing trivial strategies in co-scheduling. Well, my name is Ruslan Kuchumov. I'm from St. Petersburg State University, and co-author is Vladimir Korkhov, who is a chairman. So in this talk, I'll mostly describe our work in general terms, although the title said analytical bound. I won't go very deep into math-related things because, well, they're not that interesting to listen and comprehend. So in general, we are in this work, we are trying to address the problem of the current high-performance computing job schedulers of very low cluster utilization. And recently, in scientific literature, an alternative scheduling approach to what we have in common HPC schedulers have arisen, which is called co-scheduling. The difference between this approach and the common one, which is a reservation-based scheduling approach, where a task is simply assigned for a fixed period of time to a certain computational resources, is presented in this paper. So the problem with reservation-based approach is that task parameters are specified at the submission time, but by the user, and then the scheduler simply reserves the resources for a given amount of time. This leads to very low cluster utilization and subsequently to very long queue await time and high power consumption and etc. The reason for that is that usually the whole node, the whole computational node of a cluster is assigned to a single job, but the job doesn't often use all available resources on that node. Usually only a very small portion of these resources is utilized, while the others are idle. But at the same time, in the queue, there may be other jobs that may use those resources, and they simply can't because the whole node is claimed by a single node. Alternative approach of co-scheduling allows to schedule multiple jobs on the same computational node, given that they do not interfere with each other. But of course, this approach is not commonly used. And the reason for that is that jobs may interfere and actually cause performance degradation, which sometimes may overshadow the performance benefits from this approach. So more sophisticated methods of measuring resource requirements of each job must be developed in order to minimize performance degradation and conflicts for shared resources between jobs. But potentially, if multiple jobs use different resources, for example, one job may be CPU intensive, other job may be GPU intensive, they can potentially, of course, be scheduled simultaneously on the same node, and they won't interfere with each other. This approach allows to significantly decrease queue wait time and also significantly improve schedulers' utilizations to reduce power consumption and even the cost when we are running job schedulers in the clusters where we have to pay for resources. If we approach this problem similar to reservation-based scheduling as a static scheduling problem or as offline scheduling problems, we would have to derive some kind of a model how each task would use its resources and how its performance would be affected by the changes in the available shares of the resources, which is, of course, in practice is not that trivial to do because there could be multiple factors that affect jobs' performance, like internal factors, like changes in task input parameters, like external factors, as I don't know, the different utilization of shared network by the tasks from other computational nodes, and even the tasks themselves may affect their performance model when they are implementing some kind of stochastic or non-deterministic algorithm. So instead, we are approaching this problem as an online scheduling problem or the problem of dynamic balancing, where in tasks runtime we measure their performance using a method that we'll describe later. And then, based on these measurements, we are changing which tasks can be, which jobs tasks can be scheduled together and run together. So to provide this feedback matrix, we are using a very simple formula, which is simply a task instructions per cycle counter multiplied by CPU time fraction, which was available to these tasks, to the task that is being measured. This formula also, it's very simple. It produces very accurate results of the task processing speed measurements, and we run a lot of benchmarks using NPB test suite and parsec and different other tests, and we have showed experimentally that this metric predicts, not like predicts, but measures task processing speed with a very high accuracy, and on the right side of the slide, you can see there is a plot of a change in the task speed as measured by this matrix versus the change of task processing time, which is basically the speed, overall speed. And you can see all of the points are aligned on the line y equals x, which shows that which shows very high accuracy of this approach. So by having task processing speed in all possible combinations in advance, it's possible to construct an optimal schedule of running tasks combinations by solving simply a linear programming problem. But of course, in practice, it's not very feasible, because we would need to at first know task processing speeds in all possible combinations, and there may be a lot of them. And actually, there are 2 to the power of n, where n is the number of tasks. And we will need to know also b values, which are total amount of required work to complete this task, which is, of course, in practice is not available at start. But still, this optimal strategy, optimal solution, can be useful for comparing and evaluating other strategies. And also, with some minor modifications, it can be this linear programming problem can be transformed into an interval form, which can also be solved and applied to practical implementations. But in this paper, we mostly focus on providing other strategies, and other strategies that are more realistic, and comparing them with an optimal strategy. And for example, we have shown in this paper and in this work that a simple naive strategy of running all of the jobs in parallel can be used if a certain condition on task processing speed holds. And this condition is as simply as this formula, which is an average task processing speed slowdown rate should be less than a value that depends on the number of tasks in the systems. When task processing speed is lower than this value, we can simply run all of the jobs in parallel, and the result would be the same as if we would run some kind of an optimal strategy, which we would obtain by solving linear programming problem. And another result that we obtained is that it's possible to show that another very similar strategy can be applied very effectively, which we refer to as FCS. And the strategy is simply to search for the combination that has the highest value of task processing speeds. And we have analytically shown that the competitive ratio of this strategy is at most 2. That is, it would always perform not worse than 2 times than the optimal strategy. And actually, the later result allows us to implement similar search-based strategies in the scheduler, because well, it's possible to approximate the strategy simply by searching the proper combination that has the maximum task processing speed. And yes, let's move on. So we are now working on implementing the strategy in the scheduler, and on the right side, you can see the example of how this strategy works. It simply tries different combinations at first and tries to measure their processing speed. And then after it has found the combination with the maximum processing speed, it continues to execute it until completion of any of its tasks. And then it tries to search for another combination with the maximum processing speed and so on. And experiment results show that by allowing each task to slow down by at most 1.5 times, it's possible to reduce max span of a schedule by almost 2 times compared to sequential execution, which is kind of a good result. So in the future, we are planning to continue our work in that direction. We are planning to consider different task models. And in particular, we want to consider the task precedence constraint when a task defined in the shape of, in the form of a graph, and compute a schedule for this problem. And it's also possible to use the same approach to model dependency of task throughput on its resources as a function of available bandwidth. And this allows us to, for example, control resource bandwidth using different methods. And as a result, affecting throughput so that it wouldn't, for example, fall below a certain threshold. And another direction of future work can be to analyze historical data of previous runs of the tasks combinations in order to provide some initial estimates for this linear programming problem and provide that would allow to provide solutions that are near to optimal. So thank you for your attention. If you have any question, I would gladly answer.
Thank you, Ruslan. So we are a bit out of schedule, but we have time for one small question. So please, questions? Anyone?
Maybe I have one short question. Maybe I'm not attentive, but what about the scalability? Can we use this approach on multiple nodes or just one?
Yes, indeed, that's a good question. We did not cover it. I didn't cover it in the presentation, but of course, this method can be scaled to multiple nodes. And in fact, I didn't even state for how many nodes we are defining this problem. And well, initially we are working with a single node schedules, but the same problem can be extended to multiple nodes by simply joining all of the resources available at each node into one single node and modeling and applying the same model to this very large node, and the result would be the same. So yes, the problem scales to multiple nodes.
Thank you.
Thank you.
Thank you.
Thank you, Ruslan. So we move on to the next speaker, and the next talk is by Yulia Shichkina and Muon Ha, translation of query for the distributed document database. So Muon Ha is here. Please share your screen.
You can see my presentation, right?
Yes, we can see your presentation. So please start.
Hello everyone, my name is Monha. I am a postgraduate student of St. Petersburg Electrotechnical University, And today I want to present to you our research talking about translation of query for distributed document database. My presentation is divided into 5 sections. Introduction, creator code, methodology, testing, and conclusion of this code. Since the early 90s, the relational database are more popular. However, with increasing volume of data, there is growing trend towards switching relational database to NoSQL database. With NoSQL database, we have key value, document, column, and graph. At the same time, switching from relational database to NoSQL database leads to a number of problems such as the creation of the optimal structure of the NoSQL database, transferring data from relational database format to the NoSQL database format, the translation of queries, taking into account the cheaper computing system using for storage of a distributed database. And this paper presents the result of our research on automation of database translating from a relational format to the format of a distributed document database, in particular MongoDB and automatic constructing of MongoDB database based on existing SQL queries. We made an overview of existing work related to our work in the following area: method of translation of data from SQL to NoSQL, tool for transferring data from relational database into NoSQL, optimization of structure of a distributed database, and translation and optimization queries. And the analysis shows that at present, the problem of translation data and query of database from one format to another are very relevant. In this case, no good solution to the issue was found. There are private solutions for individual area for direct translation of table in the collection to transfer relational database to document database taking into account relationship type, to extract from document database using SQL query and query optimization methods. And in our study, an approach based on information graph was applied to study the dependency of subquery from location and availability of data in accordance with the special theme of the distributed database and information about source and replica. Based on the information graph, we will recommend an oriented acyclic multigraph. The visits which correspond to subquery within the main query and the act data transmission between them. In the method of constructing an information graph of query for distributed relational database, taking into account the information about fragmentation of table to retie a link between the query elements are considered. We excluded 3 options in the example is showed on slide. And we created a method for constructing a document database scheme taking into account structure of a distributed relational database following on slide. And based on information graph and method for constructing a document database scheme, we have developed an approach to translation SQL query to distributed MongoDB database. And for testing, 3 options for database structure were selected. First is not distributed database with sharding, and distributed database with sharding and replication. For distributed database, we added query to the subquery to the shard and translate individual query. On the slide, you can see the query execution plan for distributed database variant. And in testing, we checked the accuracy of the observation of the query before and after the translation. The slide shows the result of the test. Another test task was to determine which option parallel execution of query time will be smallest, and to carry on the testing, database with different volume are generated. On slide, you can see that volume of database and the execution time of query using the developed program. And From the test result, it can be seen that the maximum parallelization of the database query with the maximum deferred operation of the program result is faster. And in this article, we presented a method of constructing queries to the MongoDB distributed database based on the MySQL query metadata of the distributed database architecture, as well as using method for optimizing the MongoDB database or collection. The automatic query construct is based on the method which is based on information graph. Our stat result shows the correctness and efficiency of the application to build the query to distributed MongoDB database. And in the future, we plan to conduct our research on the classification of query for the type of operation and the variant of the parallelization. Thank you for your attention.
Thank you for your talk. So please, questions to the speaker. I have a small question meanwhile. So you're translating the queries to relational database, SQL, to NoSQL database, MongoDB. Is that correct?
Yes, correct.
Yeah. So are there limitations? So I believe you cannot translate any query to relational database to the NoSQL database because of different architecture. So can you say something about the limitations of this approach?
We have developed an approach to translation SQL query to MongoDB queries. Concept is for fast. In the first phase, we passing input query into store token, and in the second phase, we build a dictionary. It's a dictionary of path of query in MongoDB. We compare how can write that query in MySQL, and we create the dictionary from that token, and we will we create a tool for translate, and we also check actually operation of the query and the result of correct input query and output query.
Okay, thank you. So are there more questions? No more questions, apparently. So thank you again for your talk. And with this talk, we conclude this part of our section. So we will see you after a small break. So thank you, everybody, for participating, and see you later today.
Thank you. See you later.
Thank you.
Is on.
Good morning, everyone.
Hi there.
Oh, I can see Valery Mikhailovich. Yes?
Yes.
Oh, that's great. I was a little bit panicked about your presentation. I'm really glad to see you here with us.
Thank you.
Are there any other presenters here?
No, just a moment.
We have time, not much, but just wait. It's okay. We have the first one.
You see? You see?
Mm, 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 yes.
You see?
Now, yes. Yes, the presentation we see. I have some technical problems with the sound. I'm sorry.
You see my screen?
Yes, you can see the presentation.
Okay.
Natalia?
Yes, I'm here. Is it okay with the sound? With the sound
Yeah,
for
it's
me?
okay. I can hear you.
Mm. Okay. So I think maybe I should change the microphone, but if it's okay, I will not do anything.
Yeah, I think it's fine. The sound is a bit loud, so maybe you can just try to reduce the gain, but otherwise it's fine anyway. So
This way.
we should start again in 3 minutes.
Okay. And do you have presenters for the second and third presentation here? Maybe not yet. I can see some chat, yes, but no messages.
Okay, Natalia. So if you are ready, we are ready to start again.
Okay, thank you. Yes, I think we are ready.
Okay, thank you.
So, good afternoon, and I'm glad to welcome you all here on our workshop of computer structure and its applications. And I'm going to present our first speaker, Valery Grishkin, with a very interesting talk in the cases of monitoring the land degradation. So, welcome, Valery. We can see your presentation.
Good day.
Please, 1 second before the speaker starts. Natalia, I sent you the link for the evaluation forms in private chat.
Okay, I'll find it.
So thank you. You can proceed.
Good day. My name is Valery Grishkin, and I present our work, creation of specialized data set for satellite monitoring of the state of agricultural lands. Now, some words about introduction. Currently, there is significant progress in the interpretation of remote images of the Earth surface using various recognition systems. To train this system, large labeled data sets are required. The creation of such data sets is carried out by experts and is quite a time-consuming task. This work proposes a method for creating specialized data set for their use in monitoring the state of agricultural lands undergoing degradation. The method allows you to automate the process of creating such datasets. The datasets are generated from freely available data obtained by Sentinel satellites as part of the European Copernicus space program. The most successful recognition systems are based on the supervised learning method, which requires a large enough labeled dataset. There are a number of datasets that contain satellite images of selected regions and are designed to meet the challenges of urban and road planning. There are also datasets used for assessing and monitoring agriculture, forestry, and water resources. They contain satellite images obtained in the visible and near-infrared range, and some sets also contain multispectral images. In this table, we see some universal data sets. Among these sets, the universal data set SEN12MS deserves special consideration as it contains a large number of triplets of data types for various regions of Earth's surface. Each triplet of data obtained during all meteorological season includes polarimetric images, multispectral images, and maps of land cover areas associated with them. These data are fully georeferenced and are located on all inhabited continents. The information about these areas also contains their markup into land surface classes. Universal data sets are primarily designed to test and compare the performance of difference algorithm for identification of areas of the Earth surface. In the case of monitoring a specific region with its own specific land cover, universal data set cannot provide sufficient characteristic of the quality of identification of areas in a given region, because this particular region may not be represented in this data set. Therefore, to solve this problem, it is advisable to use specialized data sets generated for specific regions and specific conditions. We consider the creation of specialized data sets for their use in monitoring the state of agricultural lands in the certain areas undergoing sand degradation. Within the framework of this monitoring, it is necessary to identify zones of sands, considering that these zones are completely degraded and cannot be used in agriculture. It is also necessary to identify both transition zones in this area, subject to varying degrees of degradation, and zones fully suitable for use in agriculture. Значит, as input data on the basis of which specialized set is built, the data of multispectral imagery from the Sentinel-2 satellites and the results of their preliminary processing are used. These data are freely available on the Copernicus Open Access Hub. But in this table, we see a full set of data, but we use only part of them. In this slide, we see handicraft access to the data by Sentinel Hub service. And we need automotive interaction with this hub. Interaction with the Copernicus Open Access Hub is carried out using requests that are supported by corresponding Sentinel Hub service. The request itself is JavaScript code, which indicates that range coordinates of area of interest, the height and width of the resulting image in pixels, a list of channels from which the data requested, and the format in which they will be loaded. The coordinates of this requested area are indicated in the UTM system. The size of the requested area is chosen equal 10 to 10 kilometers, which corresponding to the dimensions of the resulting image, equaling 512 to 512 pixels when using a channel resolution of 20 meters. Data from channels is requested in the form of standard PNG format images. Each images include 3 channels of data. In this slide, we see requested data from images in pseudocolors. The data from channels requested in forms from standard PNG images. Each images includes 3 channels of data displayed as red, green, and blue. Since only 30 channels are used. 5 images are loaded from any given area or date. The first images represent visible part of the spectrum in natural clouds. The next 3 images. The first image is this. The next 3 images represent data from remaining channels displayed on these images in pseudocodes. The last images is the grayscale and display classification mask. This is a classification mask. Downloading the data required for exploring large areas also requires a large number of downloads. Therefore, a specially developed script is used to load data. This script generated a request for satellite data for a specified location within a specified date period. When requested data from the services, the access key is transmitted which has been obtained earlier. This key is updated early and can be obtained as a result of another request of the service. Therefore, then exchanging with the hub, the size of upload image is checked. And if it is too small, this indicated the services did not provide data. Therefore, you need the request a new key is to be requested, and the script takes care of that. For interaction with the hub, the standard CURL utility is used, this utility is a part of almost all operating systems. After request is generated, the script is passed to this utility as parameter. The algorithm for downloading data from Sentinel Hub services is shown in the next slide. We use satellite data from spring, summer, and late autumn periods. The first period was chosen because it is in this period that the vegetation color is the strongest and well determined from satellite images using standard method. The second period is characterized by completed development of vegetation, and in these images the surface that was covered with vegetation looks like so. Thus, comparing these images, it is possible to draw conclusion about location and presence of productive soils of the area under observation. Since the soil on which nothing grows is either degraded or unsuitable for agriculture purposes. We use result of preliminary classification images, SCL, scent classification, obtained during data processing by Sentinel Hub. This classification result is tied to each requested area of Earth's surface and represented as pixel mask MSCL of the images of this area. The values of each pixel in this mask corresponded to the specific types of the ground surface. This mask is used to segment areas containing agricultural soils. These areas are covered with vegetation in the spring and summer. Therefore, by segmenting such areas on images from the late autumn period, we will obtain data on the distribution of fertile soil. In this slide, we see value of pixel of scent classification mask and corresponding it to corresponding recognized type. It is necessary to form two new masks out to original summer classification mask. The M summer web mask represents the vegetation cover only, while the M summer soil mask represents the soil mask. Two similar masks are also formed out of the autumn classification mask. The first M autumn soil mask represents the soil cover, and the second M autumn wet mask represents vegetation cover. This mask is the fertile soil mask. The M good soil is equal M summer wet and M autumn soil. The next mask contains additional information about the location of the fertile soil hidden under the vegetation. MF good soil is equal M good soil, the previously obtained, or result of M summer soil and M autumn mask vegetation. In this slide, we see a result of this logical operation. In this image is a visible image of region of interest in August. This image is the visible image, the same region in October. This is classification mask in the August. This is classification mask in October. But yellow is a bare soil, and green is the vegetation. And this yellow is bare soil and green is vegetation in autumn, and this is gray is clouds. And this is image of the fertile soil mask without autumn vegetation, and this is complete fertile soil mask. In this slide we present the algorithm for creating a specialized data set for this purpose. The computed mask of fertile soils along with the spectral image of the subdomain are added to the data set. This is the algorithm for form our specialized data set.
I'm sorry, we are a little bit out of time.
Yes, only 1 minute.
Thank you.
For training, we create a specialized data set and the research some classificate this result of classificate the fertile soils and the sand by some classification. All classification gives the same result, but the best result is the random forest. That's all. Thank you for attention.
Well, thank you very much. Now then, thank you again, and we are going to our next presenter. We talk about very important workflow for data scientists. Can you hear us?
I don't listen. Listen. It's noisy.
I'm sorry, I have some technical problems. Yes, I can't do anything with it.
Hello? Hello, everyone.
Hello.
Hi, hey, Natalia. Yes, you can hear me? Wait, I will share my screen. I'm sorry, I didn't hear you clearly, so I'm not sure. It's my turn. I think I have shared my screen.
Yes, it's okay. We can see and hear you well.
Okay,
Welcome.
So, hello everyone. My name is Man Tianxing, a PhD student in Imo University. I'm glad to present our research at ICCSA conference. The topic of my research is ontology-based data mining workflow construction. So nowadays, huge amounts of data are generated in various domains. There is a significant need to extract knowledge from this data with intelligent data processing and analysis. And data mining algorithms are that are targeted to extract useful information from a amount of data can be used. By now, a considerable number of such algorithms have been developed. The efficiency of the data mining algorithms usage in practice depends on the context. Till now, the task of selecting data mining algorithms for data processing requires the knowledge of data mining experts. So this research addresses the problem of data mining workflow construction. And this is the task definition. Algorithm selection problem can be formulated as follows. Given a problem X, and it is characterized by Fx, and we need to find an algorithm by the selection mapping SFX such that the efficiency indicator mapping EAX is maximized. And the workflow construction problem is formulated as an algorithm selection problem in each process. So to build the data mining workflows effectively and correctly, it is important to have a structure framework to follow. And the CRISP-TM describes the typical data mining processes. It is formulated as 6 steps and with hundreds of activities. And each step requires the selection of the operators or algorithms. Thus, to get the effective solution, we must spend many efforts and much time. And in our previous work, we proposed a data mining framework for data mining workflow construction based on CRISP-DM. We can see that we have 4 layers. And for example, at representation layer, we use ontologies to describe the data mining knowledge. And at the server layer, we present the service to for the workflow construction. And we can see that the main part is the service layer. This layer provides the service of algorithm selection and workflow construction with the following components. We can see that the domain-oriented ontology construction module, it reconstructs the domain ontology and the data mining ontology into a domain-oriented ontology. And also we have the interactive interface to generate the corresponding queries according to the task requirements and the data characteristics. Also, we have the query module. It performs the generated queries on the domain-oriented ontology and generates the selected workflow. So in this article, we focus on the workflow construction problem. So first of all, we constructed the three data mining ontologies to present the related knowledge. First one, it is the data mining core ontology. It describes the general data mining knowledge, including the algorithms, processes, characteristics, and the goals. And the dataset characteristics and task requirements define the conditions for algorithm selection, and the suitable algorithms, modules, and measures are selected based on these conditions. The second ontology is data mining dataset characterization ontology. It defines and represents the semantics about characteristics of data mining datasets in a machine-friendly way, and it is constructed based on the integration of the high-level ontologies. We can see that OntDT and IO, and it also has the representation of dataset characteristics, this part. And the third ontology is data mining process ontology. It has a hierarchical structure, and the layers are, we can see 4 layers: phase, sub-process, action, and operator. And we also constructed a rule-based interactive interface using JUICE. It receives the user's requests and generates the needed description logic queries for querying on the data mining ontologies. And the user's requests are the task name and the entities of the ontology. The description logic queries are expressed using constructs such as and, some, exactly, and so on. And the subclasses which match the conditions are obtained. We can see that at the beginning, users input the task name to trick the JUICE engine, and for the subsequent processes, users input the entities generated at the previous steps as the facts. And the user's requests define the input facts, and the needed description logic queries are the output. And the queries are generated using the preset rules. So this is an example. Input the data characteristics at place 1. Here we can see that, and the query for suitable data mining process is returned at place 2 here. And the generated query can be performed on the data mining ontology. And we can see we perform it in the software footage, and we have the result. So this is the case study. We use the labeled phases in the veiled people dataset. It is a classification problem. And this is the step for querying for the suitable actions. We can see that we input the data characteristics here, and it is facts match the condition in the rules. And after that, we have the corresponding data description logic query. And after that, we perform the query in the protege, and after that, we have the suitable actions. We can see that in this example, we have the action diminution reduction. This is a screenshot. We perform the query in the protege. And here, with the same way, we can input the data characteristics for the suitable operators. We also can see it as algorithms. We can see that we input the data characteristics, and we have the query, and after that we have the result. The PCA is the suitable operator. This is the screenshot. And we skip some similar process, and after that, we construct the workflow. It has a sequence, the sequence of the process. Also, for some process, we need to select the suitable algorithms. We can see that the PCA algorithms is selected. And for the classification problem, we need the suitable vector classification algorithm, as we see. And we compare the constructed workflow with other available workflows. So we can see our workflow has the best performance. So that's all. Addressing the data mining workflow construction problem, we have built an ontology-based meta mining framework. And in this article, we propose a rule-based interactive interface based on rules, and it converts the user's requests to the description logic queries automatically. And a case study is presented in this article. We construct a data mining workflow from the FW dataset and compared with other workflows. So the constructed workflow achieves the higher performance. So thank you for your attention. And if you have any questions, let me know. That's all. Thank you.
Thank you, Man. I hope it's better hear me in this way. So questions from the audience? Maybe I have one short question. Is your application desktop or web? You have a web version of it, and is it your future plans to make it the web version, or it's just not suitable for this in this case?
It is suitable for most use case. We applied this approach for different domains. For example, this is a typical classification problem. We also applied it on time series classification problem, and because the performance depends on the knowledge we collected. And for time series classification algorithm, we have more knowledge, and we have a more clearly knowledge, so we have the better performance. So I think it can be applied on different problems. Yeah.
Okay, thank you.
Thank you very much.
If we have no more questions, then thank the speaker again, and we're going to the next presenter. So Igor Kulikov with the work about the telecommunication monitoring system. So we're glad to welcome you, Igor.
Good morning. Is it okay with my voice?
Yes.
Thank you.
Yes, we can see your presentation.
Can you see my presentation? Okay. Let me introduce research ontology for knowledge graphs of telecommunication network monitoring systems. Let me introduce our other teams. There are Igor Kulikov and Alexander Vadyakha from St. Petersburg Electrotechnical University LT, Elena Stankova from St. Petersburg State University, and Natalia Zhukova from St. Petersburg Federal Research Center Russian Academy of Science. Typically, the application network monitoring system are designed for network performance monitoring, emergency monitoring, and user account monitoring. However, modern network have dynamic structure, and the use monitoring system must be reconfigured when network structure changes. Also, there are monitoring tasks. They need the usage of several network models, for example, topology model and billing model for solving the problems. Traditional monitoring system cannot deal with this task without a redesign. For solving the task, telecommunication network monitoring system based on knowledge graphs were proposed. The architecture of a monitoring system based on knowledge graph has been already presented. However, the issues of development ontologies for knowledge graphs building require additional study. This research explores some aspects of ontology building, like a definition of the problem and requirements of ontologies are used for knowledge graph building, design of proposed ontology and its representation and ontology web language, and methods for the ontology integration and enrichment. Based on the scope of the task solved by monitoring system based on knowledge graph, the following requirements to the developed ontology are defined. Telecommunication networks have complex dynamic structure. The main source of information about them is operational data received from the network, and the ontology must provide possibility of describing heterogeneous static and dynamic data about telecommunication network, including the network structure and the state that are changing in time. Next, telecommunication network operators' business processes have high complexity. The execution require close interconnection between multiple information systems, including third-party systems. It is necessary to assure integration of the developed ontology with other ontologies that are used by telecommunication network operators. The majority of telecommunication network features defined by target groups of subscribers and the technical resources. These features are essential for solving monitoring tasks. A possibility for ontology extension with specific data about telecommunication network must be provided. The developed ontology should allow use standard semantic web toolset for building and executing SparkQuery requests and for logical inference. It must be possible to use the existing methods for ontologies integrations and enrichment. The following standard ontology metrics are used for developed ontology evaluation: axioms count, logical axioms count, declaration axiom count, the next class data properties, individual counts, and description logic expressivity. The proposed ontology is designed as a layered ontology that consists of the following levels: core ontology levels, domain ontology level, and application ontology level. It is based on already existing ontologies. Ontologies integration is supported on the level of core and domain ontologies, and ontology extension is assumed on application ontology level. Ontology is used as a vocabulary where a set of classes and the relations between these classes in a domain are represented. This representation has a formally defined and universally agreed structure. The main purpose of developed ontology for knowledge graph is knowledge sharing and reusing. Ontology and its instances can be represented as a domain knowledge-based. For telecommunication network domain, the ontology describes a set of network nodes, such as switches, routers, storage devices, and links between them. There is a number of existing ontologies developed for telecommunication network domain, which can be considered. Network description language, telecommunications service domain ontology, ontology for third generation wireless network, mobile ontology, ontology for optical transport networks, ontology adopted in open mobile network, and Tucan ontology TOCO. Ontologies defines the vocabulary for knowledge graph. Usage of ontologies for knowledge graph will describe heterogeneous static and dynamic data about telecommunication network using ontology classes, relations, and attributes. Usage of ontologies also allows integrate information system based on knowledge graph. Ontologies can be extended quite easy by adding new classes, relations, and attributes. In addition, ontology-based knowledge graph design allows you standard semantic web toolset, including SparkWhale for data retrieving. The layered structure of the proposed ontology is shown on this slide. The following core and domain ontologies are used for building the suggested ontology. First of all, core ontologies includes basic geo vocabulary, friend of friend ontology, ontology of units of measure, units of measurement ontology. As domain ontology, it is proposed to use TSDO or Toucan ontologies. The purpose for purpose of linking a domain layer and application layer, the set of domain ontology entities are chosen for further linking with application ontology entities using object preferences mechanism. The following telecommunication network domain ontology entities are chosen as points for linking with telecommunication network monitoring ontology. There are devices, device, link, interface, service, and data assets. In telecommunication network monitoring ontology, the set of entities and links depend on the task solved by telecommunication network monitoring system. Among the main subjects for monitoring in telecommunication network, there are user actions, telecommunication network events, and monitoring of telecommunication network devices parameters. Telecommunication network monitoring ontology was developed during this research, and the visualized version is presented in this slide. The data structure for every of cases of monitoring cases like user actions, network events, and monitoring device parameters are presented on the next 3 slides. Every case is characterized by own classification nodes and presented in the diagrams. This slide presents user request actions case. The next slide is for network telecommunication network events, and the last slide is about monitoring parameters case. The proposed ontology was developed using ontology web language, and some examples of classes description using this language is shown in this slide. About integration, ontologies integration. For telecommunication network monitoring ontology can be integrated with different telecommunication network domain ontologies used by operators as shown in this scheme. Integration of the developed ontology and on application level with other telecommunication network domain ontologies is based on using the similarity of the definitions of the subject area main entities, for example, telecommunication network devices, users, services, and interfaces, as shown in this scheme. Ontology should provide an enriched mechanism. Ontology enrichment is the process of an ontology extending through adding new elements, relations, and rules like shown in this diagram. It is performed every time when the existing domain knowledge does not allow use data received from telecommunication network. Since new concept and relations can be added during enrichment, the structure of the ontology can change. Ontology enrichment cannot be fully automated and remains typically a semi-automated procedure. It requires manual intervention of domain experts in order to review and accept or reject the system proposals. The next section of the research, the case study. The business task of our case study is telecommunication network operator uses a network monitoring system based on knowledge graph. Telecommunication network provides services, applications, and sells access to content. The operator defines new requirements to extend the information about telecommunication network that is contained in the corporate knowledge graph, and with additional analytical data, geographical data, adding device model information, and users' tariffs. These parameters allow increased operativeness of telecommunication network issues and failure solving. To solve the task, the application level telecommunication network monitoring ontology was developed and integrated with domain ontology of telecommunication network operator. Initial data of our case study. The devices used both stationary and mobile. The description of data used, data sources, and data channels are presented in the table is shown on this slide. All the data must be collected, placed in the telecommunication network monitoring ontology, and provided to operator. In the considered use case, the following subtasks are solved. The telecommunication network monitoring ontologies for described cases is proposed. Result ontology is checked against ontology requirements, and knowledge representation of received monitoring data is created. The next slide shows knowledge stream of the proposed telecommunication network monitoring and ontology. This stream includes all the necessary monitoring cases like user actions, failures collection, and monitoring of telecommunication network devices parameters. This slide shows comparison of our final telecommunication network monitoring ontology with core ontology as Geo and domain ontology TOCO. The new application level ontology for telecommunication network monitoring system based on knowledge graph is proposed in this research. Telecommunication network monitoring ontology as application ontology is linked to domain ontology with specific object properties. For defining links, entities and domain ontology were chosen, and object properties were defined in our ontology. The discussed ontology meets the formulated requirements, in particular ability to describe heterogeneous telecommunication network static and dynamic data, ability of ontology enrichment. It also allows integrate telecommunication network monitoring systems with other information systems, including third-party systems. The ontology is built according to the standards of semantic web and can be extended or changed using standard methods and tools. The structure of the proposed ontology, methods of integration with domain ontology, and methods of the ontology enrichment are studied in this research. The main ontology metrics also are provided. The case study of telecommunication network monitoring ontology building for solving telecommunication network monitoring task is also discussed. In the course of further research, extending of proposed ontology and methods of its semi-automatic enrichment will be considered. Thank you for your attention. That's it.
Thank you, Igor. Questions from the audience? I have one question about the data protection. Is it all public, or you need some, or you have some problems with it? So, is it a problem for data protection in your application?
Ontology, excuse me, thank you for your question. Ontology as information resource is open, and it doesn't require any data protection. But when we will speak about real monitoring systems, this question can be raised, and in the future maybe we should solve this issue. For now, only proposed on ontology, this information resource is absolutely open.
Thank you. Thank you very much again, and we're going to next presentation. So we have the next presenter, Jasur Kiyanov, who will tell us about our private data protection. Welcome, you, Jasur.
Good morning, ladies and gentlemen. Wait a minute.
Yes.
Can you see? Let's beginning. Recently, big data is increasingly turning from a fashionable area researching into the tool from practical use for many sections of practical activity. However, increases in the volume and decrease in connectivity of data lead serious problem both with breach of the security problem and possible data leak. The relevance of this topic in the modern world is connected with the future introduction of information technology in our life. We are become more and more dependent on information system and service, and consequently more vulnerable to security threat. Information systems that process personal data are particularly susceptible to this risk. It's enough to recall the growth of an authorization dissemination of personal data at consequence in recent years. For public cloud, this problem on sites with data quality and critical for the choose anonymization model being critical issues. The issues as data quality has been investigated is successful details, and the conclusion from this study is very strict. Before performing and work with data is necessary to check quality of data and make all possible adjustments. If the data is well prepared, you can start post-prepare the data. If the data will be prepared, you can start the data. The main stage of the prepare is the following: anonymization, data quality control, data consolidation. The architecture of the big data processing system uses complex system with which several components of the levels can be distinguished. This division is largest arbitrary signs. On one hand, each component can be divided into the sub-component, and on the other hand, some function components can be redirection dependent on the task being solved and the software being used. For example, they allocated storage to the second layer. But the main thing is protected the data from insurance. The international practice of using the personalization method is shifting toward a risk-based approach. In this case, the risk assessment is carried out in order to develop measure enough the confidently of the private information is necessary to publish the personalization data. At the same time, the volume of the information play a key role in the complexity of the depersonalization process. The emergence of the new source of information make it possible to compare with previously published available ones, which inevitably lead to lack risk re-identification of usually the personalization data. This forces us to enable the concept guarded the personalization of data in introduction certain voting for the working with the risk and building a continental process of the seeing the to personal identification information. This is transferable to the consider the virus method of depersonalization as promise and potential way to protect personal data. The process of the depersonalization of data is a part of the processing personal data aim defective personal information deleting as a result such process. New depersonalization data is generated based on the init array and information with personal data that safe for interested of the individual. As a result of using the personalization method that with various degree of the anonymization is obtained. The several methods to the measure anonymization, most of the based the concept of violence class, the ability to distinguish identical recognize data set in terms of quality identification. Anonymity indicators are closely related to the Frank's analysis to record. The probability of re-identification is usually universality property to such indicators. The following the type of the indicators and attack on them: K anonymity, L variety, T proximity. The unital indicators show that loss when the desired level of the previous research. The more general the record become, the less data can be extended for analysis, the lower the data quality become. In the limited absolute safe data from white noise, one the pricing and enough the security of personal data by building a system allow use confirm that possible reach companies between untrial and confidently. For a large amount of the data, it's important of have quality estimation usefulness of the data, which shows the quality of the data after applying the personalization method. There are several approaches to the measure and useful of the data shown in the slide. You can see first method of write scripting. This method is the most natural risk analysis science is involve the formula of those scarings that can be implemented in practice and assumed as financing result in each of these scenarios. In the special case, when each moment of time each of the recognized significant factor take an finite number of the value. Scenario 3 is completed. However, directed analysis all the possible is often impossible. Therefore, in most cases, some criteria developed by which scenarios are compared, and only a part of the scenarios called non-domain analysis. Your second method, you can see the method of Monte Carlo. One of the way calculated is the aware value condition large as number experiments. Other that for the evolution, the series random number generated by the corresponding series used. Based on this date, large number of scenarios models and sample averageable is used as estimation. Unknown mathematical experimental is accordance with the low and large number, which is the desired numerical estimation. And my conclusion, I will say, as a result of using the personalization method, that which with very degree of anonymization is obtains the security of the set released date cannot be evaluation solely the basis of the date itself. Therefore, the main parameter of the model evolution depends on the type and quality of data, not special case, different type of attack. Based on the size equalize the data itself. Thank you for attention.
Oh, thank you. Are there any questions? So I'm interested a little bit. Are you planning to use some decentralized systems for anonymization? Some like blockchain, very popular today.
Yes, I analyzing protection for the decentralization ledge. Many tested from. I will be following the 3 tips on immediately. You can be see this method. We tested all is method generalization method of successful and crypto method. We can show me is successful will be and in future I will be can be used more depersonalization method in my analysis.
Thank you. That's great.
Thank you.
Any more questions? Then I will thank all of you for your attention, and we will continue after the short break after 10 minutes.
Perfect. See you later then. Thank you.
Later. Good afternoon, everyone. I can see some of the presenters. You can test your presentation, your speakers, the microphone, if you wish. We have some time yet.
Can I try to share my screen?
Yes.
Okay, Natalia, I stopped sharing the screen, so you can try.
Okay. Can you see?
Yes.
Okay, great. Thank you.
is on.
Okay, Natalia, when you want, we can start back with the following session.
So I think we can start.
Yes.
Yes. So I'm glad to see you all here again. We'll continue our workshop, we'll start from the very exciting presentation about analysis of the seabed plants and animals. And I'm glad to welcome. We can see, yes, Ekaterina, yes.
Yeah. Good. My presentation. Can you see? That's okay. Yeah.
Yes, we can see your presentation and
Okay,
clearly hear you.
Great. Hello, my name is Ekaterina Pavlova, and the topic of my work is of our work is solving the problem of automated marking of underwater animals using a cascade of neural networks. Today, the problem of segmentation and recognition of marine life using machine learning methods is relevant for marine research in the field of monitoring bottom communities and automatic mapping of seascapes. Also, counting underwater population is necessary for analyzing the ecological state of their environment. From the table on the slide, you can see that the existing methods of marine research require significant time and money, but to analyze data from photo and video observation, it's necessary to have a labeled set of various data. Their existing databases which describe their biological diversity of their deep seabed are squared and contain little structured information. Also, the problem of creating extensive databases lies in the rarity of many benthic inhabitants. As a result of which the number of images of their certain species of animals can be very small. That is why it's advisable to solve the problem of segmentation of underwater communities with the help of neural network, which solve the class of few short learning problems, and their peculiarity of which is that with their help, it's possible to segment an object having only a few images of each species of animals and plants. Their aim of their work is to build a solution for marking and detecting sedentary underwater inhabitants. To achieve this goal, it's necessary to solve a number of tasks presented on the slide, which in turn can be divided into three subsets. First one is database formation. Next one is data preprocessing followed by segmentation. And the last one is mapping and localization. The solution we propose is based on the creating of cascade of neural network, each of which is capable to solve one of these tasks. Namely, first one is improving the image quality. Next one is segmentation and counting the coverage of the surface by individuals. Those it's possible to achieve this goal by achieving the best result at each stage. And also one of their important criteria, as I said earlier, for choosing architecture components was their limitation on their volume for their training dataset. Therefore, and first of all, attention was paid to models capable of performing the segmentation task without large-scale datasets, but performing the same task over several frames. That is, in our case, the number of training example was limited to 5 images per animal, per species. Before solving their segmentation problem, it's necessary to create a set of classes of different types of animals and plants. After that, their object is detected, the data preparation stage begins, without which it is impossible to proceed their segmentation stage. And with the neural network, since their neural network needs small datasets with target object that must be segmented in the image. However, many open databases of marine life contain either few species or use rectangles as their frame of object, and therefore often fines and body parts can be cut off. Automatic generation of a dataset consists in solving their unsupervised segmentation problem, as a result of which you can automatically create classes and mark masks for each of the segmented objects. As a result of our research, a sample set of 6 images was created for each of 60 species. Due to their nature of underwater video, a high image is one of the most common obstacles to accurately applying the mask to an object. So a method was also tested, or another method, when the video sequence was divided into frames, to each of which a super resolution model was applied to increase their clarity of the frame. The resulting solution is shown on the slide. So the video sequence of underwater shooting is divided into frames, which in turn undergo preprocessing, and by using a neural network, and increase their image resolution. Segmentation of objects from database is performed on the frame that already have passed preprocessing. The slide shows the input data or masks and the resulting segmentation of segmentation 5 shot, 5 ways. A more detailed description of the neural network used in which we used is presented in the table, where the first was used to form a dataset, the second solved the future learning problem, and the last one increased their resolution of incoming frame. At the third stage of mapping and localization, based on the data obtained at the previous stage about time, frame, coordinates, and volume of segmented objects, we used their open source tool and open access territorial models for creating an interactive map on which the investigated habitats are visualized. So their framework was created, the sequence of action of which is presented on the slide. After splitting the video sequence into frames, each of which undergoes preprocessing using a super resolution model, then the objects are segmented using their prepared support sets, and after calculating the area of segmented objects, the results are displaying it on the map. The slide the slide shows their result applying their model to solve unsupervised segmentation, and this one is result of few short learning segmentation. So with the help of the presented architecture, it's possible to successfully solve the problem of automated marking of underwater animals. The use of new algorithm for improving images and segmentation of underwater objects to automate monitoring and counting population can significantly reduce their amount of time spent compared to traditional methods of studying marine life. Also, the resulting solution can be used as a basis for creating extensive databases for the subsequent training of static segmentation models. Thank you for your attention.
Thank you very much. Questions from the audience? And from me, I'm interested for which cases, maybe you maybe not clearly here, but in which cases do you use this method? So is it already has a practical use, or just it's your future plans?
It wasn't tested on their in real life, but we had their video sequence. They was like that, and on this, it's our target to working with this type of video sequence, from real life, that can be applied in real life. Yeah.
Thank you. And are there any limitations for such use, or it's just for any problem, for any task?
Not any, but only for underwater animals and plants. Our target is to counting it and just to just to analyze their bottom communities. Limitation can be only in time, but as I said earlier, it's faster than their traditional methods that can be taken now.
Okay, thank you very much. Maybe some more questions. Now then, thank you again, Ekaterina, and we are going on to our next presenter, Anton Gavrikov, with his presentation about the wind estimation for large ships and some small seaboats. So, welcome, Anton. We can see your presentation.
So Today I would like to talk about our work on wind simulation, and let's start with question why we need it. We're creating a testbed for ship motion simulation. Our modeling approach is based on autoregression, for which we need to know the autocorrelation function for wind speed. We are interested in measurement frequency around 1 second and velocity for each axis, so that we can accurately account for different gusts. Since we were unable to find any suitable data, we decided to collect it ourselves. Ready-made solution for 3-axis anemometer costs too much, and most chips anemometer are designed to measure only velocity magnitude. So we decided to build our own anemometer that would be able to measure wind speed on each of the axes. The anemometer is assembled so each wind will measure a particular axis by increasing the pressure on that wing. Otherwise, the effect on of the wind on the wing is minimized. To measure wind velocity, we strain gauges mounted on the arms lined perpendicular to axis directions. Inside each arm, we placed aluminum load cell with 2 strain gauges, one on the bending side and another one on the lateral side. To get our velocity from this from gauges, we use Bernoulli equation, from which we already got the velocity value for the axis directly. Pressure force F acting on the load cell, which is written in second formula, and arms in which load cells reside have front and back side which much larger areas than the left and right side, therefore we neglect forces on them. So simplifying this formula, we finally get system for our velocity. As we use one-dimensional autocovariance function, where A, B, and C is parameters of this function that controls the shape of exponent, but we have positive and negative values. So for each axis, we use 2 distributions as in second formula, where B is scale parameter and C is shape parameter. This is our autocovariance function, and here A, B, and C is parameters of our shape, but as we need 3-dimensional version of our function, and one of axis is time also, we just multiply them and get this 3-dimensional function. So we need to collect data, and we install an anemometer on tripod and placed it on the balcony and collected data. We calibrated our anemometer using commercial anemometer and a fan that rotates with constant speed. First, we measured wind speed that the fan generates when attached to commercial anemometer. Then we successfully placed the fan behind and in front of each arm of anemometer and measured values that the corresponding load cells reported for each side of arm, with and without fan. So, in which way we calculated the coefficients calibration for our anemometer. Also, we notice that ambient temperature affects values reported by our load cells. When the load cell heats up or cools down, it reports values that increase or decrease linearly in time due to the thermal expansion of the material. So we removed this linear trend from the measured values using linear regression. So from here starts a verification section where we try to fit our data into some distribution or compare it with some real data. And here is slides which show us wind velocity by each axis. Also, horizontal lines show overall average speed, and yellow area show us days when Emercom of Russia reported wind speeds above average. As we can see, it correlates in some way. That is good. So let's continue our verification. We split our data into 2-hour intervals and try to fit each of them into Weibull distribution, which we discussed earlier, using least squares fitting. Negative and positive wind velocities projection to each axis both have this distribution, but with different parameters. On this slide, you can see the best fit and worst fit distribution for each axis. Here, red line shows estimated probability density of positive wind speed projection. Blue line shows estimated probability density of negative wind speed projections. And circles denote observed probability density of wind speed projections. As you can see, our data fit good enough with max error 6.7% with x-axis. Also, we approximated wind direction by another distribution, which is von Mises distribution, using the same method, the same least squares fitting. There is best approximation for our interval on the left and on the right, and worse on the left. Same as on previous slide, red lines for positive values, blue for negative, and circles for observed values. Error slightly bigger than on the previous slide, but it's still good enough. To ensure that our anemometers provides an accurate time series, we compared its results with those of commercial anemometer. Both anemometers were set up in the field near the shore, and data were collected simultaneously. The results showed that there is some correspondence between the measurement of the two anemometers. Afterward, we computed autocovariance for each axis as our ACF for one dimension. Per axis ACF have pronounced peak at nut log and long tails. The largest normal Ramassia is 3.1%. Variances for x and y axis are comparable, but ACF for z-axis much lower variance. The best fit and worst fit ACF for each axis presented on this slide. Red and blue lines and circles denotes the same things as before. Finally, when we verify our data from anemometers in many ways, we finally trying to get parameters for our model to use it in our virtual testbed and compare it with results of our anemometer after simulation. We used one of interval with best fit results to find parameters for our function, and we get these results. We found that velocity and direction distributions and ACF of each axis of simulated wind and the real wind are similar in their shape, but they are too far away from each other. So we managed to achieve good accuracy for different distributions, for Weibull distribution and for von Mises distribution. We understand that pre-axis anemometer is useful for statistical studies, but it's unable to measure immediate wind speed and directions. Also, as I said before, shape of final results from our test, but the same with real wind, but they're too far away from each other. And our future work is to construct array of such anemometers to measure spatial autocovariance. So that's all. Thanks for attention. Any questions?
Thank you very much. Questions from the audience? So, only one. Maybe you said just about the accuracy, and is it good enough, or you can somehow improve it for such kind of models?
Accuracy is never good enough. Also, we collect our data on the balcony, so there's also some effect on final result because wind direction was the same, and this affects on our distributions on our data in some ways. Also some kind of such thing as rain, snow during measurement also affect on this kind of anemometers, because z-axis is collect all this snow and water and increase its pressure. So maybe it can be improved in some ways, but we didn't think about it yet.
Okay, thank you. So I understand it's a real problem to collect the data.
Yeah, it's very bad when you can find a good one.
I understand. So maybe some more questions. If not, then thank you again, Anton. And I'm trying to understand if we have the next speaker with the again.
You have.
That's great. So I'm glad to present Alexander Bogdanov with another presentation about the forming of ocean waves and connecting with the ocean, with the waves. So, well, please welcome Alexander.
I don't see. I don't see the presentation in the screen.
We do not yet.
Because I have it on a computer, but I don't have it on a.
You need to set which part of the.
No, I understand, but I see choose what to share. There are 3 screens and not screens with my PDF file. I can see it on my screen, but I don't see it on a share screen. It's very strange. Maybe I have to ask where are my PhD students. Sorry, one moment. Ребята, у меня не это самое. Не открывается PDF-ка на share.
We'll wait for some time, and maybe our next presenter is ready, and if it's clearly. Okay, I think that maybe we will change the order of our presentations, and the next will be Ivan Ivankevich with his presentation, and then we will turn to Alexander's presentation. Are you ready, Ivan?
Yes, I'm ready. Do you hear me?
Okay. Yes, we can hear you.
Okay. Should I start?
I guess yes. I think it's okay.
Entire screen. Okay. So do you see my screen?
Yes, we can.
Okay. So let's start. So let's start. Hello, my name is Ivan, and my talk is about functional. My talk is about functional programming interface for distributed computing. So this is the work that was completed by my student. His name is also Ivan, but surname is Petrikov. Our motivation for this work can be summarized as the follows. We have some experience with distributed computing and HPC computing, but we never saw like universal technologies that are used both in industry and in academia. So in academia, we use MPI technology, which is de facto standard for supercomputers and for HPC clusters. But in industry, we use something like Hadoop or Spark or something else as a basic technology to that we can use to write our programs. So our first point for the motivating point for this work was to investigate if there is some universal low-level representation for distributed computations that can unify both MPI and big data-based approaches. Our second motivation was to investigate if there is some high-level interface for functional languages which can be used to again for distributed computing. In functional languages, we have several abstractions. The most popular abstraction is like some functional form that allows you to compute other functional forms in parallel. So it's like maybe it's a fold or a reduce or map or something like that. However, these forms, we haven't found the technology that can be used to make these forms distributed, so that you can use them to write a program that works on each node of the cluster. So these forms are limited only to a single node. But we found several papers that did something similar for distributed computing. And the third point is that all existing solutions do not provide automatic fault tolerance for slave and master nodes. And the paper that we found also doesn't provide this this feature. So why it is important? Fault tolerance is important in distributed systems because they are composed of commodity hardware, and this hardware fails. And if you run your program for several days, which is a usual scenario in HPC, you can't afford to lose the data that was generated by a program that was run several days. So it's too much resources, and it's too much money to lose such precious data. So in this presentation, I used two terms. The first term is parallel, and I use this term to describe computations within single node, and the term distributed is a term that describes computations across several cluster nodes. So we do not study here geographically distributed clusters because we do not have access to such technologies. So what we came up with is interface, programming interface, which is universal enough to describe both big data and HPC applications. So I will describe it in using examples, small code examples. And here we use C++ because we wrote the implementation in C++. I hope this will be easy for the audience. So here we have our idea is to replicate regular function call stack and adapt this stack for parallel applications. So we want to be able to copy this stack to another node, and we want to be able to transfer the data which is used as arguments of functions and as local variables of function call stack. And here we can see example of a simple function which we call nested. This function takes one argument and returns some value. And this is the regular. In the left column, you can see a regular program, and in the right column, you can see the program which is rewritten using our asynchronous call stack. Here you can see that we replace the function with the structure, which is derived from the kernel class, and we have moved the result of the computation to the field of the class, and we moved the argument of this function also to the field, one of the fields. And then we have this act function, which contains the body of the original function and contains special statement async return. Async return makes it possible to return to the parent kernel, so to return to the function that called this nested function. But this statement does this asynchronously, and you do not need to actively wait to use the result of the nested function call. So we call this asynchronous call stack like kernels because of this class, because of this base class which implements all the details. And here we can see the second example. This is the main function that calls nested function from the previous slide. and we can see that here we assign the result to some variable, and then we print this result. And using the kernels, we can rewrite it the following way. We have the act function that creates nested kernel and calls this special function async call. Async call places the nested kernel into the queue, and the queue is processed by kernel by the thread pool in parallel. So every kernel that you put in this queue will be processed in parallel threads. And then we have this new function which we call react. This function accepts child kernel as the argument, and then we cast this child kernel to the class that we need and extract the result field. Then we print the result and again call the asynchronous return. And then we have alternative main function in this asynchronous function called stack, which creates main kernel, places it in the kernel queue, and then waits until all kernels finish their execution. This implementation is fully asynchronous. All the local variables and all the arguments are contained in the structure fields, and the return from the function and the function call is replaced with special asynchronous alternatives, which instead of the call place the kernel into the queue, and then the call is performed asynchronously by other threads from the thread pool. Why we did the implementation like this? We want to, since every data is contained in the kernel fields, we can write this data to the file or to the network connection or to some other medium, and then later read it from this medium on another node, or possibly on the same node. The kernels provides us with a way to distribute the computations over cluster nodes. So that's why we used structures instead of the regular functions, because we can't copy function called stack because it can contain pointers and references to memory locations which are invalid on another cluster node. So we created these kernels, and we now need to create the scheduler for these kernels. The scheduler is composed of two processes. One process is daemon process, which is run on each cluster node, and this process has one queue for each device, for each concern of the scheduler. So the first device is of course processor. So we have processor queue. The second device is network cards. So we have a network queue which sends kernels to other cluster nodes, and also we have this special process queue which is not linked to any device, but this is a separate concern of our scheduler. This concern means that we want to launch child processes in order to run applications in these processes. So we want to isolate our daemon process from application processes. And in each application process, we also have a similar architecture. We also have processor queue, and we have a process queue which is linked to the parent process. Using this architecture, we can run kernels on any node. We can run them locally, and we can run them on remote nodes, because we can transfer them to other nodes by copying their fields and then restoring them on another node. And also we using this two process architecture, we can route all the kernels through daemon process. And this means that our scheduler, which is run inside this process, can control the whole the whole stream of this kernel. So this process is responsible for distributing them across nodes, and we have rather sophisticated algorithm which is used for kernel distribution, which is usually called load balancing. And we can take into account any parameter of the node, so we can take into account like temperature, the load on the processor, the load on the memory, and so on and so forth. So we can use any parameters from any node. And also the scheduler maintains a list of available cluster nodes, and it uses kernels to do this. So we have a separate kernels to maintain the actual load, the actual parameters of all nodes in the cluster. And also we have this third call, async message, to implement like synchronization of this information between cluster nodes. And so the slide describes how we implemented fault tolerance. For us, this is the main idea of this implementation. So here we assume that any application has main kernel, and this kernel has only one step kernel at a time. So the main kernel has only one child kernel at a time, and this child kernel can have any number of child kernels at a time, so it can use parallelism. And what this means in reality, it means that our programs are sequential, so they contain sequential steps, but each step is internally parallel. So we can synchronize all the computation after each step, and then we can use any number of child kernels to implement parallelism. So in this scenario, when we assume that the program behaves this way, we can list all possible scenarios when any combination of kernels fail. Okay, so okay, I probably should be faster. Okay, so in any scenario, we can restore the failed kernel using either its copy, which is made always for all child kernels, because we have a copy on the original node, and also we made manually the copy of the main kernel and send it together with the step kernel on another node. So this is described in several papers, and we covered all scenarios with this simple technique of restarting the kernel and copying the kernel to another node. Okay, so I will skip this, and I will talk about the results. So we implemented automatic parallelism for functional languages, which is based on kernels. And what we did, we implemented functional forms like cons and like cons in parallel. So when you see cons here, it computes its arguments in parallel to each other. So since this function is recursive, we can create a lot of parallelism from this simple modification. And internally, this is all implemented using kernels, so we get all the benefits of kernels. We get fault tolerance, we get automatic load balancing, and we get this asynchronous execution. So our results for the automatic parallelism are presented here. We had to rewrite the fault form because the fault form is not parallel, but fault pairwise is parallel. So when you reduce your list in pairwise fashion, this is parallel. And as you can see here, the automatic parallelism reduces the time when you use these forms, but replace the implementation of this language with the implementation that uses kernels. So okay, the conclusion of this work is that we have two conclusions. First of all, we have these kernels that provide automatic parallelism, automatic load balancing, and the universal interface for cluster computations. And also we have this high-level interface, which is based on arguments parallelism. So our idea was to compute all arguments in parallel. And actually, if we compute all arguments of the conf call in parallel, this is enough to make fold and map parallel in this language, which is very surprising to us. And also, this automatic parallelism hides the shortcomings of parallel and distributed computations, which is typical for high-level functional languages, because they hide any problems that lower languages have. This slide concludes my presentation. Thank you for attention, and I'm ready to answer your questions.
Thank you very much. Maybe one short question from the audience.
May I ask, please?
Yes, of course.
Ivan, thank you for the brilliant presentation, as always. And I have two small questions. So one is, you talked about fault tolerance. So how many nodes can fail together in such a way that the program still keeps working? And the second question right away, can you say something about the scalability of this thing? So how many nodes can work together such that performance is not degraded?
Okay, thank you for the questions. The first question, how many nodes simultaneously can fail? In our current implementation, only one node can simultaneously fail. So but we can guarantee that if only one node fails, that we can restore from this node. But if all nodes fail due to electricity outage, this scenario also covered. So this works. And about scalability, we tested this approach only on small clusters because we do not have access to larger clusters, but it works on 10 nodes. So, but the scheduler without applications works up to 1,000 nodes. We checked all the algorithms which are used by the scheduler but are not used by the application. So on virtual nodes. So we tested up to 1,000 nodes.
Thank you.
Thank you, Ivan, again. And we're turning back to our third presenter, Alexander Bogdanov. Please welcome. The floor is yours.
Good afternoon, dear convener. Good afternoon, ladies and gentlemen. I am sorry for the problems that we were having. Most probably the system for conferences we are using doesn't like Linux, because we managed to launch applications only via Chrome browser. So I will try to launch it right now, and hope it works right now. Share. Okay, do you see it?
Yes, we can see it.
Okay, thank you. Today I would like to speak about some of the realization of our package of programs for computation of strong nonlinear waves. And now we are facing actually two problems here. First problem is just to organize the computation in such a way that there would be no standard complex problems for such kind of computation that are first of all the appearance of so-called artifacts that distort the way and doesn't appear in real life. And the second is that due to the change of the order of the operator in computations, there are different kinds of obstacles that cause the loss of the data in computation, and actually that also brings the disturbance in the stream. Now we are coming to the program of the strong nonlinear waves, and this program has another phase. This phase is that necessity to compare the results to the real life situations, and we are now have possibility to model such waves, and the modeling of such waves makes it necessary to compute them at a rather fast speed, rather high speed, and this high speed actually need to arrange both software stack and the hardware that we are using for that purpose to run in optimal way. To discuss these problems, we took a more or less standard approach to the strong nonlinear waves that is based on so-called Kadamtsev-Petriashvili equation. Kadamtsev-Petriashvili equation is a nonlinear equation that has standard quadric nonlinearity, and it also has additional problems that is caused by the different types of behavior and the different types of high order derivatives in two dimensions, in x and y. This actually gives us the possibility to work with the integral variant of this equation, and this integral variant of this equation is much more stable than the original differential variant, and actually it is possible to damp somehow the artifacts that are produced by the fact of the changing of the operator if you come to discrete variant of the equation. In standard computation of such type of equation, and that is more or less typical for hydrodynamical computations, you have a very severe problem because you have to launch several flows of computations, and these flows of computations exchange very strongly with the data. This exchange is very easily done on vector facility, but if you do it on a graphic card, general purpose graphic card, it's not so effective. You have to take steps to organize it. And to organize it, you have to make the your codes, you have to make your algorithm absolutely symmetric so that you could use some transformation of the variables to adapt it more or less to this slow exchange of data between the flows of data. That means that we have to make a finite difference method for this equation, very strictly symmetrical. And since it is non-linear, you have to use implicit finite difference schemes, and with implicit finite difference schemes, you have to use iterations. On these iterations, you are normally using the data during the iteration, and so you have to make a correction procedure that is called flux correction procedure. Sometimes flux correction procedure causes artifacts in computations, and we have to take care of them. To do it in a proper way, we have to use different steps in two dimensions, in x and y, and to choose these steps in such a way that you don't have artifacts in computations. Also very important is to choose the approximations of the derivatives. Since you have to work with the higher order derivatives, second order derivatives in y and third order derivatives in x, you have to take care that they should be absolutely symmetric, so you have to have a 5-point run in the computations. Even if you do it very properly, you have the problem of finite size of the area in which the computation is done. That means at certain time you have the waves that approach the boundary, they are reflected, and of course this is non-physical reflection. Also, if you come to the integral form of these equations, you have unphysical integral influence of the data that are collected by the integration on the wave, and this integral effect actually causes the deep dives in the wave, and so you also should take care of that. More than that, the conditions above are opposite to the transfer part of the equation, and basically you have to take care to correct the transfer type of the equation to introduce the transfer in y direction that is absent in initial equation. So when all this done, you should carefully test the instrumentation part of the experiment, and actually we used this configuration that is described on this slide, and we had to use both types of parallelization to make it run, both parallelization in data and parallelization in task. Otherwise, the low memory of the GPU makes it very slow, and we have to make it very fast to compare it to experiments that are organized for these waves. I will not discuss what types of data we were using. It's not so interesting. There are just some results of the computation. You can see here elapsed time and 5 different experiments with the parallelization. It's first type of parallelization. We just add the GPU to the principal CPU, and this GPU runs as a vector processor for the parallel application of the derivatives. But although it was about order of magnitude faster, that was not as fast as it was necessary for comparison to the experiment. So after that, we made 2 types of parallelization, as I described earlier, the parallelization in data, the parallelization in tasks, and actually we managed to decrease the time of the computation almost another order of magnitude. And that means actually that we have about 2 orders of magnitude speed up if we organize this properly. What can it do for experimenting is actually can be shown on the next slides, but I would like to say that this 100 times of speed up for this computation make it possible to use standard workstation that is used for organization of the experiments to make the computation in real time. I would like to show some of the results. Actually, we made 2 types of experiments. First of all, it's just the wave that goes in smooth water, and the idea of the experiment is to show the exponential growth of the wave in certain conditions, and you can see in these next figures how this exponential growth is realized. But the final idea of the experiments was to see how the waves in the ocean influence this exponential growing way, and experimental result actually says that it is quite different if it goes with the waves or if it goes opposite the waves. And actually the plan was to show that it is really that case, and now you can see the 2 cases, and you can see that there is a strong difference where the wave goes with the wave of the ocean and in opposite direction. That means more or less that we manage to see the effect of this, of influence of the waves in the ocean on this exponentially growing way. And if it goes in backward direction, we can compare it to experimental result that this exponential growing way is died down with the waves going in opposite direction. And as a conclusion, I can say that we managed to organize a computational complex that can manage these nonlinear equations, and this experiment complex is suitable to go in parallel with experiments. And we hope that we can compare these results sometime when they are more complicated with the behavior of the ships on the waves. But that should take much more time, because we should add there a lot of other features. But still we are happy with the results, and we are happy that we from our experiments we can see that we understand at least what is done in the experiment. Thank you very much for attention.
Thank you very much, Alexander. Some questions from the audience? Maybe not. The presentation was really interesting and clear enough. No questions. Thank you
Okay,
very much.
thank you. Bye.
For this, I think we're closing our workshop, and thank you all of you in participating in scientific computer infrastructure workshop, and hope to see you all next year personally, not online. And thank you. Have a good day and a good conference. Goodbye.
Thank you. Goodbye.
Thank you, everybody. Thank you, Natalia, for chairing the session. See you
Thank you
next
too.
year. Bye.
Bye.
So now I will ask you to leave the room, please. And if you want, you can join the other rooms for the other sessions.
Okay, thank you.
Thank you.
Non c'è prendo 5